In this video I want to introduce you to SORA, because SORA is completely awesome. SORA is the tool from OpenAI, the tool that can create videos out of text. And the fun part is that SORA is also a word simulator, or at least it should be a word simulator in the future. More on that of course later in the course, and I will also show you some concept of this research paper in this video, but first we take a look at the videos from SORA. This right here comes directly from SORA. This is the introduction video. So they simply want to show us what SORA can do without any modifications. So here you see the prompt, a cartoon kangaroo, basically in a disco, and you see this thing is dancing and this looks really good and enormous coherent. Then the next prompt, the golden retriever puppies in the snow. You see also the playing of these puppies, this looks really enormous good. Also stuff from the nature works of course really well. You see the camera zooms in and you can imagine how all of this will go in the future, because you can create stuff out of thin air. You can make stuff that is like not realistic, but you can also make stuff that is realistic. You see longer prompts with a lot of descriptions, and you can also see that, like, I think this model understands physics. Yes, you can see all of these generations, they seem that the model understands physics at least a bit, because all the people, they move like they should move. And every time you see something in nature, all of this moves really coherent. There are basically ships in black coffee, and they are floating around like this model understands physics. Also the people, they are looking really nice. This thing looks also really good, and also the cat is nearly as it was real. You maybe also think that mammoths are back in civilization, because all of this looks enormous. Now enough with the videos, let's just take a look at the research paper, because SORA has the potential to be a word simulator. They tell us right here, we explore large-scale training of generative models on video data. Specifically, we train text conditional diffusion models jointly on videos and images of variable durations, resolutions, and aspect ratios. We leverage a transformer architecture that operates on space-time patches of video and image latent codes. Our largest model, SORA, like the stuff that you already saw, is capable of generating a minute of high-fidelity videos. Our results suggest that scaling video generation models is a promising path towards building general-purpose simulation of the physical world. This sounds awesome, because OpenAI tells us they will scale these models, and these models understand physics. And this is really promising. And maybe you think why these models should understand physics, or what should we do after these models can understand physics? We can do all of it, because we can basically just like simulate other worlds. Maybe you saw the TED Talk from Jim Fan. Jim Fan is a guy from NVIDIA, and he talks about Isaac Jim. I just want to explain it really quick here. At NVIDIA they made a model that can simulate worlds. And in these worlds, they train robots to do stuff. And they can train these robots really fast. And as soon as the robot can do stuff in the simulation, it can also do stuff like in the real world. You should probably see this TED Talk for yourself. I just did this like really quick here. But they try to simulate the physical world to train robots. And if SORA can do this on a really high level, we can do all of it. We can train robots in these simulations. Now back into this paper, here you have also a lot of examples, and here is how this works. So basically, yes, this is just a diffusion model. So you make pictures, you make a lot of different pictures, but they also work similar than a large language model. Here you can see it. We take inspiration from LLM models with acquired generalist capabilities and training on the internet scale data. Here OpenAI simply tries to tell us that these models, they work similar to a large language model. An LLM is, for example, ChatGPT. ChatGPT makes tokens out of text, and basically SORA makes these pictures smaller, it chunks it down into patches. This is basically the same stuff as tokens, and then these models can be more efficient. At a high level, we turn videos into patches by first compressing video into lower dimensional latent space, and then basically decompressing all of it into patches. Here you can dive deeper if you want, but I don't think we need to do this. You can also see that they use this diffusion model, so they start out of the noise and they start with the denoising process. And here you can also see the difference between that computing power. The first video here, this is base computing power. Excuse me for my slow internet, but I think you can see it. So the first video, this is the slow computing power. Then the second video here, you can see 4x the computing power. And the video starts to work like a lot better, a lot more coherent. And then here the last video, this is 32x the computing power. So you see they need really a lot of computing power to scale these models. Sam Altman from OpenAI even tried to raise $7 trillion for computing power. He wants to make chips, and if you see this, that you need like 32x the computing power, you also understand that this thing needs a lot of compute. You can also make different resolutions, so you can make stuff for Instagram, for Facebook, for YouTube, for whatever you want. Also, the coherence underwater is really good. You can also start with pictures. So you can start with a picture like this Shiba and you can animate it. This looks really good and really nice. The second animation is also good. And the cloud that tells us SORA is really amazing. And here is one of my favorites. This is enormous. We start with this small little wave, and then we go into this big wave. This wave is really cool, at least in my mind. Extending of generated videos is of course also possible. We can make endless loops. You can see this for yourself on the webpage. We can start with input videos and we can lay prompts over it. Just imagine what these things can do. You can create whole films with these. This is completely mind-boggling. And you can also see, you can start with a video and then make other stuff into the video. So here you see it gets into something really funny. You can even play Minecraft if you want, because all of this is generated out of text. Just look at it, this is really coherent, this is how the game Minecraft looks like. I think this is completely mind-boggling. So this is SORA, and of course I know right now we cannot use it, but I am relatively confident that we can use this relatively quick. And as soon as we can use this, I will make updates. SORA is more than just videos. Just think about the applications. If you want to create a whole film, you can do it with SORA. Just like 1 or 2 people, if you have a narrative, you can create whole films with these. It was never possible until now. If you want to make a film without AI, you have to hire like a gazillion people and you need to spend millions and millions of dollars. Right now, maybe you can do it with a strong GPU and SORA, or at least as soon as we have access. But don't worry, we will take a closer look at the tools that we can use right now in the next videos, because we can really make a lot of stuff even without SORA. But I think SORA is the next level. SORA is the next cool thing because it can also understand physics. It has the possibility to simulate whole worlds, at least if we believe what OpenAI tells us.